For nearly half a century, Voyager 1 has traveled farther than any other human-made object. Long after leaving the giant planets behind, it continued its lonely journey into the vast darkness between the stars. Every signal it sent back to Earth became another chapter in one of humanity's greatest adventures. Its mission was never meant to last this long. Engineers expected the spacecraft to gradually lose power as its systems aged. Eventually, one day, its instruments would fall silent forever. Until then, Voyager's job remained simple: keep listening, keep measuring, and keep sending home whatever it could find in the unexplored frontier of interstellar space. But imagine a different story. Imagine that during an ordinary communication session, mission controllers noticed something that had never appeared before. The spacecraft responded to every command exactly as expected. Temperatures looked stable. Power levels remained within predictions. Navigation data appeared normal. Yet hidden beneath the routine telemetry was a strange pattern. Tiny fluctuations repeated with astonishing precision. At first, no one considered the discovery important. Deep space missions often produce unusual data. Cosmic radiation, weak signals, and aging electronics can create unexpected results. Small irregularities are part of exploring the unknown. The engineering teams assumed the mystery would disappear after the next transmission. Instead, it became stronger. Every new signal arriving from billions of kilometers away contained the same repeating sequence. It wasn't random noise, and it wasn't caused by a damaged antenna on Earth. The pattern refused to vanish. Experts began checking every possible explanation. They examined Voyager's onboard computers, reviewed decades of engineering records, and recreated countless hardware failures using identical equipment preserved from the original mission. Nothing matched. The spacecraft behaved perfectly. Meanwhile, scientists studying the surrounding environment noticed another curiosity. The magnetic field surrounding Voyager appeared unusually organized. Tiny variations appeared where researchers expected almost complete randomness. Plasma measurements also showed subtle changes that challenged existing models of interstellar space. None of these observations proved anything extraordinary on their own. But together, they created a puzzle. Was interstellar space more complex than anyone had imagined? For decades, scientists pictured the region beyond the Sun's influence as a place shaped mainly by thin plasma, magnetic fields, and energetic particles drifting through the galaxy. Now, this fictional scenario suggested there might be hidden structures spread across unimaginable distances. The possibility fascinated researchers. Some proposed enormous magnetic currents flowing between nearby stars. Others imagined dense regions of charged particles acting like invisible rivers through space. These ideas remained speculative, but they followed known physics. Then came the theories that stayed outside official discussions. Late at night, after meetings ended, conversations became more imaginative. What if Voyager wasn't simply passing through empty space? What if it had entered a region where physical processes behaved differently from anything humanity had previously observed? No evidence supported such an extraordinary conclusion. Still, history has shown that many scientific breakthroughs begin with observations that initially seem impossible. As the weeks passed, the mysterious signal continued returning with remarkable consistency. Artificial intelligence systems searched through enormous collections of data, comparing Voyager's transmissions with pulsars, quasars, cosmic rays, and natural radio sources throughout the galaxy. Nothing produced the same signature. Each failed explanation only deepened the mystery. The oldest spacecraft ever built appeared to be reporting something no one expected. Whether the answer involved unknown plasma physics, hidden magnetic structures, or something entirely unforeseen, one fact remained unchanged. Voyager kept moving forward. Farther from Earth. Farther from the Sun. And deeper into one of the least explored regions humanity has ever attempted to understand. In reality, Voyager 1 continues to provide valuable scientific information about interstellar space, helping researchers improve models of our cosmic neighborhood. But in this fictional story, its greatest discovery had only just begun. Every new transmission hinted that the darkness between the stars might hold far more complexity than anyone had ever imagined. And the next signal would become even stranger. Days turned into weeks, and the mystery surrounding Voyager 1 refused to disappear. Each transmission took nearly an entire day to cross the unimaginable distance separating the spacecraft from Earth. Every command sent by mission controllers required patience, and every reply became another piece of an increasingly complicated puzzle. The strange signal remained. It wasn't growing stronger, but it wasn't fading either. The repeating pattern appeared at nearly identical intervals, quietly hiding inside otherwise ordinary engineering data. No words. No recognizable code. Just a mathematical rhythm that seemed almost too perfect to be accidental. Researchers from around the world joined the investigation. Radio astronomers searched for distant cosmic objects that might be interfering with Voyager's communications. Plasma physicists modeled enormous clouds of charged particles drifting through interstellar space. Computer scientists tested millions of simulated hardware failures. Every experiment produced the same conclusion. None of them recreated the mysterious pattern. Then another surprise emerged. In this fictional story, Voyager 2, traveling through a completely different region beyond the outer planets, began reporting subtle magnetic irregularities of its own. The spacecraft wasn't detecting the same signal, but the timing of its measurements showed unexpected similarities. Individually, the observations meant very little. Together, they suggested something much larger. Could interstellar space contain invisible structures stretching across enormous distances? Some scientists imagined giant magnetic filaments connecting different regions of the galaxy. Others proposed that vast waves of plasma slowly drifted between nearby stars, creating conditions never before observed by human instruments. These possibilities remained speculative but scientifically interesting. Then imagination took over. Suppose those repeating patterns weren't simply caused by unusual physics. Suppose they were the natural consequence of entering a region unlike anything humanity had previously explored, a place where magnetic fields, energetic particles, and gravity combined in ways that current theories could barely describe. No evidence confirmed such an idea. Yet the possibility inspired endless debate. Artificial intelligence systems continued searching for hidden relationships within the data. Most discoveries turned out to be meaningless coincidences, but a handful of statistical patterns refused to disappear. They hinted at an underlying order that no existing model could explain. The deeper researchers looked, the more uncertain they became. Sometimes the greatest mystery isn't finding an answer. It's realizing that the original question was too small. For decades, humanity asked whether anything remarkable existed beyond the edge of our solar system. Now, in this fictional tale, a different question emerged. How much of the universe remains completely invisible to us? Voyager carried no powerful cameras capable of photographing distant civilizations. It possessed no advanced laboratory designed to solve the universe's greatest mysteries. It was simply an aging spacecraft, built with remarkable engineering and extraordinary determination. Yet sometimes the simplest explorer travels the farthest. As Voyager continued its silent journey, its famous golden record remained safely attached to its side, a small collection of Earth's music, languages, laughter, and greetings intended for any distant intelligence that might someday discover it. In reality, no evidence suggests that anyone has found Voyager, answered its signals, or detected the spacecraft in interstellar space. Its ongoing mission continues to expand scientific knowledge about the environment beyond the heliosphere. But fiction allows us to imagine what science has not yet observed. Perhaps one day humanity will discover that the galaxy is even stranger than today's theories predict. Perhaps future explorers will cross boundaries that transform our understanding of space itself. Or perhaps Voyager's greatest legacy will simply be proving that curiosity can travel farther than any machine. Until then, the tiny spacecraft will continue drifting through the darkness, carrying humanity's story into the unknown. And somewhere beyond the familiar stars, the next great discovery may already be waiting.